Yes, children, today we're going to solve one problem based on triangle chapter. In right triangle ABC, we have a right angle triangle ABC, right angle at C. Angle C is 90 degree. M is the midpoint of hypotenuse AB. AB is the hypotenuse, M is the midpoint. If M is the midpoint, this means BM is equal to AM. C is joined to M. C is joined to M and produce to point D such that DM is equal to this, DM is equal to CM. It is given. Point D is joined to B. D is joined to B. We have to prove four parts. Number first, triangle AMC congruent to triangle BMD. AMC means this triangle congruent to BMC, this triangle. So for proving the first part, for proving any congruency, we have to note down that we have to identify three equal parts in it. So in triangle AMC and triangle BMD, two part we already are observing. AM is equal to BM, DM is equal to CM. Third part, we're going to take these two angles which are vertically opposite angle. First we're going to write the part of triangle AMC, then BMD. So in these two triangles, AM is equal to BM. First part, AM is equal to BM. Why? Because M is midpoint of AB. Angle 1 is equal to angle 2, angle 1 equal to angle 2. Why? Vertically opposite angles. Number third part, CM is equal to DM. CM is equal to DM. It is given. So we can say both the triangles are congruent. And by which criteria? These two triangles are congruent by side angle side. By side angle side congruency. Number second part which we have to prove is angle DBC is right angle triangle. DBC is equal to right angle triangle. So in this figure, in triangle ABC, it is given angle C is equal to 90 degree. If we are going to prove angle C is equal to angle B, both the angles are equal, then we will get angle DBC, this angle equal to 90 degree. So for that, what we have to do, we have to prove this complete angle ABC congruent to triangle DBC. So what we will going to do, this was the first part. Second part, taking these two parts, since triangle AMC congruent to triangle BMD, or we're going to add triangle BMC on both sides, we'll get triangle AMC plus triangle BMC congruent to triangle BMD plus triangle BMC. What we did, we added this triangle BMC. This is common in both of them. If we're going to add this in, we'll get this complete angle DBC and this ACB. So that's why we are adding, or adding these two, we'll get triangle ACB. Triangle ACB congruent to triangle DBC. Triangle DBC. These two triangles are now congruent, and we know that when two triangles are congruent, then their corresponding parts are equal. Since corresponding parts of congruent triangles are equal, therefore we can say angle C is equal to angle B. Angle C is equal to angle B. This implies that angle B is equal to 90 degree, as angle C is equal to 90 degree, because angle C is equal to 90 degree, it is a given. So this will give angle B is equal to 90 degree, and we can write its complete name. Angle B means DBC, or angle DBC is equal to 90 degree. So second part we get. Again from this we can also take one more corresponding part we are taking in this two. Angle C is equal to angle B, angle A is equal to angle D, angle A is equal to angle D. This will be used in the third part. Angle A is equal to angle D. We're going to underline A. So now moving to the third part. Third part we have to prove triangle DBC, means this complete triangle congruent to triangle ACB. So we are separating both of them. DBC triangle DBC and triangle ABC. ABC. In these two triangles, third part we have to prove these two triangles are congruent. So in triangle DBC and triangle ABC, angle B is equal to angle C, we have just proved. BC is equal to BC, it is common, and angle D is equal to angle A, we have proved in the second part, that is angle A is equal to angle D. This was the proof. So these part we are going to take for proving these two triangles as congruent. So we'll get angle D is equal to angle A, proved above. What is the reason? Proved above. Angle B is equal to angle C, it is also proved above. And BC is equal to BC, it is common. So therefore we can say both the triangles are congruent. By which criteria? Angle side. By angle side congruency rule. And when both the triangles are congruent, then their hypotenuse are equal, means CD is equal to AB. This will be used for proving the third part. This implies that CD is equal to AB by CP CT. Now fourth part we have to prove CM is equal to half of AB. Fourth part, CM is equal to half of AB. Now coming to the main figure, we have to prove CM is equal to half of AB. First of all, we are observing CM is the part of the line CD. CM is equal to DM. So we can write CM is half of CD. We can write CM is half of CD. Why? Because these two parts are equal. So on the basis of it, we'll get the fourth part. Since CM is equal to DM, this implies that CM is half of CD. Since these two lines are equal, so we will say CM is half of CD. This complete line, it is half. Now in place of CD we can write AB, because CD is equal to AB. This implies that CM is equal to half of AB, proved above. Or we can write equation number first from equation first. So this way we can prove all the parts. So this is the fourth part that we have to prove. Thank you.